All right. So basically, for this part of our lab, we had a comparator module which had two inputs, an A and a B. And what it does is we compare them bit by bit, and the output's always going to be a 3-bit output. And the order is either if A is greater than B, and that's true, then we're going to have 1 there, and then the two following bits will be zeros, and then it's A equals B, and then A less than B, so that's the order. And if any one of those is true, it outputs a 1 for that bit. And then we were able to incorporate the ALU because of its 4-bit output. We were able to concatenate that with the 3-bit output of the comparator, which the only effect that has is that because the ALU has 4-bit output, the first bit, the most significant bit, is going to be a 0, and then the remaining bits are just going to be the 3 bits of the comparator, which is A greater than B, or A equal B, or then the final one is A less than B. And that's all.
The next thing we'll be talking about is this module here named top, which is our VGA controller. And this makes use of a clock as well as several counters. So if you look here, you'll see that this is instantiates other modules. This clock divider here essentially turns the 100 megahertz clock into a 25 megahertz clock. This horizontal counter just is a counter for the horizontal pixels in the VGA display, and this is for the vertical ones. You'll see that there are 5 outputs: H sync, vertical sync, red, green, and blue. So this is for the horizontal sync and the vertical sync, and then these are the values being pushed to the constraints file for the VGA. And you'll see here that these all use a conditional statement. And essentially what it's saying is if the H count value and the V count value are within a certain range, it's gonna make the red, green, and blue values a certain value for each one respectively. So in our case here, red is going to be very strong, while green and blue are going to be very weak signals, which means if it's inside of this designated range, it's going to print a red square, and then anything outside of that range is going to be black. And that's why you'll see in our demo that the VGA just shows a red square surrounded by black. One thing that was successful about this lab was figuring out the VGA controller and how to implement that into our project. We had to do research on things like counters and a clock divider here in order to get this to work. And speaking of counters, we used that as well, and a button debouncer in order to use a button in our project essentially as a toggle to display a red square in the middle of a black screen and make it disappear by the push of a button.
Yeah, and so with that being said, we also had one failure, which wasn't really considered a failure because we did create a multiplier and we were able to get that working and everything, but we just weren't able to really incorporate it into the rest of the things other modules that we had in the lab. But that was just due to time constraints. But other than that, with the work that we did on the VGA and the push button input with the counter, we think that we had a successful attempt at this lab.
For our lab 3, we made sure to implement the 7-segment display mode that will display the answer in in decimal. So here we'll do 1 plus 1, and it'll switch to display 2. For our addition to the input, we included the use of a button. And for our ALU design, we created a comparator and added that to our ALU and our decoder. So if we input 2 1s and then the code for our comparator, we'll see that this will compare the 2 values, 1 and 1, and will output a 2 if they are equal, which they are. If we increase the value of A to 3, 3 is greater than 1, so it's going to output a 4. And then if we make B greater than A, it will output a 1, which means A is less than B. And then we added the use of this button here to implement our VGA display, which is our surprise component. And if you can see here now, the screen is black, and when you push the button, a red square appears. And if you push the button again, it disappears.